Hello everyone. So far we have created our contract structure and we finished our init module function. Now we are going to continue with the rest of the functions. Now first of all, here I'm going to create a public function. I'm going to call it get vault address. It's going to have an admin address. It's going to be type address, and we are going to return address, and we are going to say it acquires vault signer capability. Again, we are using this acquires so that we can let Aptos know that for a short time of being, we will be using this resource, so it's not going to be available to use anywhere else in the network. By saying this acquires vault signer capability, we are making sure that there will be no problems such as race conditions and other bugs in the network. And we are going to use this methodology, saying acquires, for the resources that we actually acquire in the function. By saying acquire, I mean that we are going to retrieve it from the storage and we are going to read it or write it, and then at the end of the function, we give this back to the storage. And between these taking and giving, we will acquire it, and we need to let the function know that we are going to do this. Let's say let vault signer cap equals, I'm going to say borrow global vault signer capability from admin address and return me the cap. Now here I said that I'm going to borrow this from the global storage. Now here I say I want to borrow this vault signer capability from the global storage, and I need the reference of this one. And then I pass my admin address. I'm saying I want to borrow this from the global storage, but I also need to give the location where it is located. And since we have moved this vault signer capability in the init module function to our resource account, which was the admin, here we are also getting this admin as the parameter, I'm checking if this address has this vault signer capability, and I'm borrowing it from there. And this is going to me the return reference, and by saying that cap, I am actually getting this cap, which is the vault signer cap. And here I acquired it. So again, I want to borrow globally this object from this address, and at the end I want to retrieve this field of this structure. This is going to give us the vault signer cap that we have embedded in here, and I'm going to say account get signer capability address. I'm going to pass the vault signer cap. Again, from account, I'm calling this get signer capability address, and as the name suggests, this returns me the address of this signer capability, and I'm passing vault signer cap. So here, what I'm actually saying is, retrieve me the address that this signer has the capability to sign for. So basically, I'm saying that I have an object and I have a signer capability. And this signer capability has capability to sign transactions for this object. And now I'm going to give you this signer. You just tell me the object that this address can actually sign for. So the address that can actually sign for is our admin address. This object is our vault object, and the address that's going to be returned here will be the vault's address. Now, at the end, this function is going to return us the object of the vault. We have this admin and the vault, and in the middle we have the signer capability, and we are making use of this signer capability to return the object's address that is associated with this signer capability. Let's create another public function, but this time it's going to be an enter function, meaning that it can be called from the front end. Now I'm going to say deposit tokens. Let's say admin signer. Let's give an amount, how much we want to deposit. It's going to acquire vault and vault signer capability. Now let's say that admin address equals signer address of admin. Now through the signer we got the address of the admin. Now we are going to get the vault address. We will say get vault address and we are going to pass the admin address here. We are going to say let vault and now we retrieve the vault object. I'm going to say borrow global. So I want to borrow this globally, this vault object from this vault address. Now first I got the admin's address through the signer. Then I got the address of the vault using this helper function. And finally, I'm returning this vault so that I can actually work on it. Now we are going to say coin transfer. And I want to transfer Aptos coin. I want to transfer it from admin to vault address and finally amount. Or here you can actually use this vault address. You don't need to say vault address. You can directly say this vault address because we already have it. Now again with this transfer function what we are doing is I want to transfer coin and this is a type of the coin that I want to transfer and I want to transfer it from admin to this address and I want to transfer this much of an amount. I want to say vault dot total balance. So I want to update the total balance of the vault since we have deposited some tokens. But the thing is I said borrow global here. So by saying borrow global, I cannot actually work on the object that I have retrieved. For this, I need to say borrow global mute. This means that give me as a mutable object so that I can actually change something on this object. So now I can say vault dot total balance equals to vault dot total balance plus amount. Now we have updated the total balance and finally we are going to emit our event. Here we are going to say emit event and we are going to give this object mutably. I will say vault dot tokens deposited events tokens deposited event and it is waiting for an amount here. Now again, here we actually got the vault. We got the admin's address. Through the admin's address, we got the vault's address. And through the vault's address, we got the vault itself. And then we have transferred coins to this vault. And we have updated the balance. And finally, we emitted the event. Now, next function is allocate tokens. In this function, we are going to allocate token for a user. We will have the admin, so only the admin can allocate tokens. We will have this address, let's say address, and we will have the amount of tokens that we are going to allocate. We are going to say it acquires vault and vault signer capability. So the first part is going to be a little routine. I'm going to say admin address is equal to the signer address of admin. We will say let vault address is equal to the get vault address and we will pass the admin address here. Now we are going to say let vault equals borrow global mute. We will say vault here and finally vault address. Now that we got our vault, we are going to check by saying assert. So assert check if the first part of this function, if it's correct, then it just moves on. But if it's wrong or it fails, then it's going to return the error that we are going to pass. Let me show you. We are going to say vault.admin is equal to the admin address. If this condition is correct, then no problem. But if these are not equal, then it's going to return this error, which is not admin. Now let's create another one. Here we are going to check vault.total balance is bigger or equal to the vault.total allocated plus amount. And if this is not the case, we are going to say insufficient balance. Now that we have checked the necessary constraints, now we are going to say let current allocation is equal to the if. So we are using this if let. On the left hand side we are going to have this variable, but on the right hand side we are going to have an if else statement, and the result of this if else statement will be stored in this variable. So I'm going to say if table contains vault.allocations address. So if this address is already in this vault.allocations, then we are going to say, let me open a block here, table borrow vault.allocations address, as I will return 0. Now what happened here is that after we check if this address is already in this allocations table, then we are going to actually get this value. So to do this, I'm going to call borrow function from table, and we are going to pass this vault.allocation. So this is the table that we want to borrow, and as the key, we are going to give this address. So this is going to return us the value corresponding to this key, which should be U64, because we define it like this in here. If you look at our struct, we have this allocations table, we have address on the left hand side and U64 on the right hand side. Given this address, we should retrieve this amount. This is going to be a reference, so I don't want the reference, but I want the actual value. To go to reference from the value, we use this ampersand here, but to go to value from the reference, we use this asterisk mark here. So this is going to give me the reference, and here I'm dereferencing it and getting the actual value. This is the location of the table, and this is the key that we use to retrieve the value from the table. And if we cannot find this allocation, then we just return 0. This means that we haven't created this allocation and it's just 0. We got the vault, we made the checks, we got the current allocation. Now it's time to update our table. I'm going to use table absurd, and this means that update what we already have, and if we don't have it, then just create it for me. Because if we have it, we get it here, but if it's 0, it means that we don't have it and we need to create this new entry. So I'm going to say it's mutable vault.allocations, and here I will give address as the key and current allocation plus amount as the value. Next, I'm going to say vault total allocated equals vault total allocated plus amount. And finally, we are going to say event, emit event. We will say mutable vault dot allocations made events, and it waits for 2 parameters. We are going to say address and amount. Now let's have a quick look again. We got our vault and we checked if the sender of this transaction is the admin and if we have enough balance. And if these conditions are correct, then we are going to get the current allocation from the table. And if we cannot get it, then we are going to return 0. After that, we create a new entry or update the entry that we already have in our table. And then we are going to update the total allocated. And finally, we are going to emit our event. If you look at our struct here, we have this allocations and total allocated, and these fields will be the ones that's going to be affected from the allocation. The total balance doesn't change, admin and vault address doesn't change, and also this allocation made event is going to change because we are going to create a new event and put it in here. So these are the only areas that's going to change, these three fields, and that's what we did in this function. Now, in the next part, we are going to create the claim and withdraw token functions. Thank you very much for listening to me so far, and I will see you on the next part.